Yeah. Good morning, my dear boys and girls. Okay, good morning, my dear students. Right? I hope I am audible. Right? My video also visible to you. I am audible. Right? Good. Last class we have seen how to analyze a continuous beam. Okay. The topic currently I am discussing with you is nothing but analysis of continuous beam. It means what? Continuous beam is a indeterminate structure. Okay, what it means? Actually, you know what is a determinate structure. Determinate structure means you can determine the support reactions using the equations of statics alone. Okay, equilibrium equations of statics alone you can determine, right? But a continuous beam is an indeterminate structure. It has more than two supports. Okay, so using the equilibrium equations of statics alone, you cannot determine the support reactions. Okay, to solve such a problem, indeterminate structure like a continuous beam, what we do, we apply a principle called a theorem of three moments. Okay, by applying the theorem of three moments, first what you have done, you have determined the support moments. Okay, there are more than two supports in a continuous beam. You have determined first the support moments. For that, you have used the principle of theorem of three moments. Okay, and then after determining the support moments, we have computed the support reactions. Okay, thus we have solved the problem. We have analyzed the continuous beam. Okay, so that's what you have learned so far in the last few classes, right? Today we will see. So far you have seen only continuous beam with the simply supported ends. Okay, now we will see. Suppose in a continuous beam at one end support is fixed. Okay, at the beginning, first end is fixed support, or last end is fixed support, or both are fixed support. How to solve such a problem? Okay, that's what we are going to see in today's discussion, right? So I will project the notes to you. Right, this is the one. That is equations of three moments applied to continuous beams with the fixed end supports. Right. Here we have a continuous beam. Right. Here we have a continuous beam. Right. Earlier you have seen problem with the simply supported end here. Simply supported end here. Simply supported end here. Okay. It's an intermediate support. Right. Now the one end is fixed now. Okay. So to solve such a problem, what to do? You have to assume a zero span. Right. You have the given beam here. This is simply supported. Support B also simply supported. C also simply supported. A is fixed. Okay. So just left side of A, what you are doing, your imaginary beam you are assuming here. Okay, which is called a zero span beam. Zero span beam. The span value is zero here. Okay. Likewise, you are assuming. You are naming it as A1. Okay. So you are getting a imaginary span called a A1A, zero span. In other words, zero span, A1A, and then AB, and then BC. Okay, now you have to apply theorem of three moments this way. Which way? First, you have to consider span A1AB. That is span A1A and AB. Okay, this you have to consider. This two consecutive spans, and you have to apply the theorem of three moments to these two spans. Okay, you will be getting two equations, right? And then you have to consider the other two spans. Which one? AB and BC. AB and BC you have to consider next. Okay, and you have to apply the theorem of three moments. You will be getting two equations, right? So thus, you will be getting another equation. Totally, you have got two equations. First, I will repeat. First, consider span A1A and AB. In other words, beam A1AB. You consider first. Investigate. Apply theorem of three moments. You will be getting one equation, and then take the other subsequent spans, which span AB and BC. Okay, these two spans you take AB and BC. In other words, consider span ABC. Okay, apply theorem of three moments. You will be getting another equation. Totally, you have got two equations. Okay, there are two unknowns. We don't know the moment at A, we don't know moment at B, but we know the moment at A1 is 0, C is 0. Okay, only these two are unknown. We have got two equations containing the two unknowns. By solving those equations, you can report the moment at A and moment at B, the unknown. Okay, once you have determined moment at A and B, it is easy for you to compute the reaction, support reactions. Okay, that's what. So here there is a problem given. A continuous beam ABC of uniform section with the span AB and BC as 4 meters each. Okay, is fixed at A and simply supported at B and C. The beam is carrying a uniform distributed load of 6 kN per meter run throughout its length, right? Find the support moments and the reactions. Also draw the bending moment and shear force diagrams. Okay, so span AB is given as 4 meter, span BC also given as 4 meter, given data, and the UDL is 6 kN per meter. That are the given data. First, bending moment diagram for UDL taken. Okay, first what to do? You are computing the simply supported bending moment diagram. Each span UDL is there, so WL square by 8. That is 12 kN meter, found to be 12 kN meter. So you are first computing the simply supported bending moment. Okay, so that's what I run. Again, for another span also, WL square by 8. Okay, which also 12 kN per meter for both the span AB and BC. First, the simply supported bending moment diagram is drawn. First, this is drawn. Okay, this is the simply supported bending moment diagram or free bending moment diagram. Okay, free bending moment diagram or simply supported bending moment diagram, you can call it 12 kN meter. Okay, 12 kN meter, which is parabolic variation. This we know by just considering this one. Span AB as simply supported beam, span BC as simply supported beam. You have to draw free bending moment diagram. That is simply supported bending moment diagram. You have to draw first. Okay, next what to do? In the beam, you assume a zero span here. Okay, and name this one as A dash or A1, whatever it is. Okay, you can name it as A dash or A1, right? It's not clearly shown here. Either A1 or A dash is written here. It's not clearly shown. It's okay. This zero span you have considered at the left side of the fixed end. Okay. Thus, you have got beam A dash, A, B, C. Okay. It has totally 3 spans now. Right. Next, what you have to do? Now you have to apply the theorem of 3 moments. Okay. Applying the theorem of 3 moments for the spans A1A and AB. Okay. Spans A1A. This is span A1A and then span AB. Now you take these 2 spans. Okay. Apply the theorem of 3 moments. What is that? It is given here at the A1. Okay. At 0th span A1, the moment is 0. 0 into it is 0 span. The L1 also 0 here. Plus 2 MA into the 0 span L1. Okay. Plus actually here it is L1. No. L2 is the next one. L0, the first one is that is 0 plus L1 plus moment at B, at support B, okay, into that span L1, right? Here it is taken as L1, this is L2, this is L0, right? Right. Is equal to 6A0 X0. You know all this formula, several times you have seen it. Okay, so you have to take moment of the simply supported bending moment diagram about the respective support you have to take. That's what. This we have seen several times. Okay, you know how to do that. Just that is the only difference. Now you are applying because you know all the values. Okay. Now you are getting this expression. A1 x1 bar is yet to be computed. So you are determining moment of the area of bending moment diagram. Okay, due to the simply supported bending moment diagram is there. No, it's a moment about the support you are computing, which is since it's a parabolic variation 2/3 base into altitude into L1 by 2. Okay, we do symmetry. So you are computing it. It's found to be 64. Next is substituting this value in this equation, in this equation here. So you are getting this value. Finally, you are getting a formula 2MA plus MB is equal to 24. Finally, you are getting an expression or equation. You are getting an equation 2MA plus MB is equal to 24. Say equation 2. Okay. You need not write as it is in the textbook during exam. You as much as possible simplify your computation. For that, you in your notebook you write in your own. You compute again. Okay, in your own style, in a simplified way, without much steps. In a simply with less steps, you write it in your own way. Next, you are now apply the theorem of 3 moments for the span AB and BC. Take the next 2 spans. Okay, first you consider 0 span and AB. Now you consider span AB and BC. Okay. Now you apply. That's what. Take span AB and BC. Now you apply the theorem of 3 moments. Oh, you know how to apply. Okay. If you apply it, you are getting this way. But the MC, the last span moment is 0. We know it is a simply supported end. Last end. No. There the moment is value is 0. That we know that we are substituting here. And after simplification, you know how to determine A1 x1 bar. Okay, divided by L1 plus 6 A2 x2 bar divided by L2 and all. How to determine, you know, how to take moment and all. By doing all such things, Because already you are familiar. You have learned it. By this time, you should work it out. You should work it out and you should have familiarity. That is your responsibility. Okay, just by listening to me, you cannot 100% understand everything unless you apply your mind and do your own in your own. Okay, so this much only I can tell. If you do it, finally you are getting this equation, right? What is that? 2 MA plus 8 MB is equal to 96. Okay, after computing all the necessary values here, finally you are arriving at this one, because this computation already we have seen several times. Okay, so by this time you should do a practice. You maybe, I hope you are familiar with that. Is equal to next equation. Now you solve this equation 2 and you have to name it. This is a 2 equation, 2 and 4. Solve this 2 equation. Okay, so by solving that, your MB is found to be 10.28 kN meter. Now you have determined the moment at B, and then substituting this value in equation 2, we get ME equal to 6.86 kN meter. Okay, so this support moments have been determined. The support moments have been determined, right? Now what to do? Next step is to compute the support reaction. You have determined the support reaction, right? So how to compute support reactions? For that, I will tell you here. Go to MB, right? This is the MB. Where is B? B is here. What is the moment here? It is obvious. At A, the moment is hogging. At the midspan, it is sagging. Again, at B, the bending moment is hogging. At C, it is 0, right? We know that. So at B, the bending moment is hogging. So that is why I have written this MA is equal to this MB, moment at B is equal to, which is a hogging bending moment, right? Which is substituted with the negative sign, minus 10.26 is equal to, here I have to write hogging bending moment with the negative sign and sagging moment with the positive sign at the RHS side, because already in the LHS, I have written hogging moment with the negative sign. Okay, in RHS also, I have to write hogging moment with the negative sign, because this sum is equal to this one. No, algebraic sum of this one is equal to this value. That's why we know the moment at MB. Now I am computing from the suppose the loads, how to get what is the bending moment at B now. Okay, that is RA into 4, which is sagging. The support reaction RA tends to produce, just imagine at B you have put a clamp fixed, and then you are applying RA. This RA tends to bend the beam in a sagging manner about B. Okay, it tends to bend. It's not tends to rotate. Please keep it in mind. Tends to bend. That is important. Okay, sagging. Okay, so which is positive. That is why RA into 4. Okay, but they have taken this span. I'm sorry, they have taken this span. From this year, they are taking moment about B. Okay, span B is under consideration. Taking moment about B is this one. Okay, that is bending moment about B. RC into 4. This RC tends to rotate the beam. Just imagine you have fixed here. This RC tends to bend the beam in the sagging manner about B, right? So that's why it's positive. So RC into 4. Okay, next to the UDL. Just imagine you have fixed here. Okay, your focus should be only on 3 items. Here it is fixed. The beam, the UDL under consideration. This UDL tends to bend the beam this manner, in a hogging manner here. So it's why negative. Okay, so minus 6 into 4 is the total UDL, into 4 by 2 is the central distance from the support B to the line of action of UDL. Okay, that we have computed. From this, RC is found to be 9.43 kilonewton upward. So the assumed direction is right. We have assumed RC acting upward. We are getting positive sign, so it is right. Okay, so on support reaction at C is determined. Okay, next for span AB. Now you are coming to span AB. So by considering span AB, what is the moment at B? MB is equal to, okay, MB is equal to, MB value it is written minus 10.28 is equal to MA plus, okay, I will come to that. MA is 0 already. You need not put MA. Sir, MA is there. MA exists. I'm sorry. Because MA dash only A1 is 0. MA exists. Now, by considering this span AB, I am computing bending moment at here. Okay. Now, MA. MA is here. It is a hogging bending moment. So MA into this one RA, which is sagging, right? Into 4 is written here, right? MA plus RA into 4 Okay. Okay, actually, the MA here is it's a hogging. Later, its value substituted with minus sign here. Please, while writing here, they simply write MA without mentioning the sign. Okay, plus RA into 4 is sagging. It produces sagging bending moment about B, minus the UDL produces again hogging bending moment. That's why minus 6 into 4 into 4 by 2. It's not the right way of writing. They're supposed to write here itself. It's okay. Slightly the author confuses the sign convention here. It's not 100% crystal clear here. It's okay. Now the MB is hogging bending moment. That's why minus sign. The moment at A also hogging. That is why now the values are substituted with minus sign. Only here the author has adopted sign convention properly, because RA into 4 is a sagging bending moment. 6 into 4 into 4 by 2 is a hogging bending moment. For hogging, negative sign. For sagging, positive sign, he adopted. Only MBA is simply written without sign. Later, while substituting its value, is taking into consideration its nature. Okay, it's a hogging, that's why minus value. This is a hogging, that's why minus value. Now, the RA is found to be 11.14 kilonewton. Therefore, support reaction B is equal to total load minus RA plus RC. So, the support reaction at RB also determined. Thus, the support reaction at C, support reaction at A, support reaction at B all are determined. So, thus we have analyzed the beam. Now, your job is to draw the bending moment shear force diagram. This is the way you have to draw. You know how to draw. Once you got all the support moments and support reactions, you know how to draw bending moment shear force diagram. For that, by this time, you should have got familiarity. It is your responsibility. Every time that we can't do the spoon feeding, you have to apply your mind and you have to learn, because we have learned things like that, right? So the bending moment diagram is simply supported bending moment diagram here, and then the support moment. Okay, that is the moment at A is found to be 6.86 kilonewton meter. Okay, it's a positive. Actually, the simply supported bending moment is positive one. Okay, but the end moments are hogging. That's one negative. So this is minus, right? Here also it is 10.28 kilonewton meter minus value. Here it is 0. So the the end moments are drawn here. The end moments are drawn here. So only the shaded area is the bending moment diagram, because the simply supported bending moment diagram is positive 1. The support, the moment support moments are negative 1. Okay, so subtract from that. That's why this white portion null area, right? Only this is the bending moment. What is the value here? Negative. Here it is positive. Here it is negative. Here it is positive. It's not shown. The diagram, it's not properly shown. It is a negative bending moment. Here it is, you are supposed to write plus here. Here you are supposed to write minus. Here you are supposed to write minus. Here it is plus. Okay, here it's sagging. Thus, the bending moment diagram is drawn. Now, once you know the support reaction, how to draw shear force diagram, you should know. Because the support reaction at A is found to be 11.14 upward. That is why the shear force diagram is drawn ordinate 11.14 upward. Afterwards, UDL is acting downward. No. Now, you compute the UDL value, which is 6 into 4. Okay, you compute it. Now you subtracted it from 11.14. So that much, since the UDL is acting downward, that much it has to come down. Okay, come down to here. Okay, if you subtract 11.14 minus 4 into 6, you are getting minus 12.86. That is why it's come bottom side, minus 12.86. And then there is a support reaction at B. The total value is found to be how much? Support reaction at B. B is found to be 27.43. Already 12.86 is here. The remaining should be 14.57. So totally put together 20 how much? 27.43. This plus this put together. So that much it goes up. The shear force diagram goes up. You have to start the shear force diagram here, upward. Then because of UDL, it is a triangular. We know all the properties of SFD diagram. Keeping the properties in mind, you have to draw it. Okay. Again, support reaction at B is upward. This much value totally it goes. Okay. Again, there is a UDL acting which is downward. Again, triangular. Okay, linear variation should be there. So this much. The support reaction here 14.57 minus this one. Only this ordinate you have to take 14.57 minus the 6 into 4 here. will give you minus 19.43. So sorry, 9.43, minus 9.43. So minus 9.43. It comes here. Again, the support reaction RC is 9.43. That's why the shear force diagram goes up to this one, center. This way, you have to draw SFD diagram. For that, you should know the properties of BMD diagram and SFD diagrams. Once the support reactions are known, you can draw shear force diagram. By this time, from the load diagram, how to draw shear force diagram. From the shear force diagram, how to get load diagram. All such things you should have got practiced by solving so many problems from various textbooks. Okay, so don't think it is the responsibility of the teacher to do all spoon feeding and keep everything in your mind. No, the teacher will say, he will teach something, especially the concept. It is your responsibility to work hard and compute and apply your mind and struggle and learn things. Okay, because we also have learned like that only during our school when we were student. Please remember. Okay, just like that we have not come up. Of course, I have to thank the teacher who taught us. Everything will not come into mind when the teacher teaches. Okay, so later we went and we applied our mind and we studied in our own and we solved because of hard work. We have become professors. Okay, so please, I advise you to do hard work. Suppose if you don't understand, you interact with your friends who has understood well. This way you have to learn things. That is my kind advice. Okay, repetitively I have been advising like that. So one more problem. What is the next problem? Don't worry, it's a lengthy problem. You will not this kind of, you won't get this kind of lengthy problem during exam. You need not worry. But you should know how to solve it. Okay. A country's beam ABC of uniform section with the span AB and BC are as 6 meter each is fixed at A and C. Okay. Now this beam is fixed at two ends, first end and last end, A and C, and supported at B as shown in figure. Okay. Find the support moments and the reactions. Draw the SF and BM diagrams of the beam. Okay. So what is the only difference here? Just I will tell you the difference. Later you can even go through. I need not teach you once again. See, this is the given problem. Only two span, AB and BC, but A is fixed, B also fixed. Okay, UDL is acting here point load is acting. Okay, this is a load diagram. Now, how to analyze such a beam, how to solve such a beam, how to analyze such a beam. Okay, to do that, in order to apply theorem of three moments, what to do? You have to assume here, since here the end is fixed, here you have to left side of this, just before the fixed end, you have to assume a zero span. Okay, the moment also zero, the span value also zero. Okay, similarly here the end is fixed. After this end, you have to assume a zero span. Now, totally how many moments are there? There is a moment exists. At A moment exists, at B also moment exists, at C also moment exists. Because why at A moment exists? It's a fixed end. It's not a civil supported end. That's why moment is there at A. Moment is there at B also. Moment is there at C also because it's a fixed end. There are three unknown moments. Okay, we want three equations. For that, what to do? You assume zero span here, zero span here. Now you take these two consecutive span. Which one? A1A and AB. First you take. Apply theorem of three moments. You will be getting one equation. Okay, good. Name it as equation 1. Next, take span AB and BC. Okay, take span AB and BC. Consider span AB and BC. Okay, apply theorem of three moments. You will be getting another equation. Name it as 2. Okay, now take span BC and CC1. Okay, the zero span here. BC and CC1. Apply theorem of three moments. Okay, you will be getting an equation. Name it as 3. Now you have got 3 equations containing the unknown, moment at A, moment at B, moment at C. We have 3 unknowns. We have got 3 equations by applying the theorem of three moments. Okay. Now you solve the equations for the unknown. That's all. This is the concept. You will be getting moment at A, B, and C. Okay. So now I have told you the concept of solving. It is your responsibility. You have been selected on merit. No, just like that you have not come and joined with the Pondicherry Engineering College. You people have been selected by merit. Okay. You people are capable of studying yourself. So whatever I told you is clear to you. I have conveyed the concept to you. A good teacher is supposed to convey the concept to the student. Okay. I need not tell you each and everything, how to do multiplication, division and all, I need not tell you. So I have told you concept. Several occasions I have already in the previous problem, I have taught you how to apply theorem of three moments and how to compute these values and all. Okay, I hope you are familiar. First, you draw the simply supported bending moment diagram. This is simply supported bending moment diagram because its UDL is acting. Here, point load is acting. Okay, WL by 4 is the bending moment here. So, next, simply supported bending moment diagram. Then you apply theorem of three moments by considering zero span here, A1A and then AB. First, investigate these two span. Apply theorem of three moments. Next, to go to span AB and BC. Apply theorem of three moments. Next, to go to span BC and C1. Apply theorem of three moments. You'll be getting three equations. Solve the equations for the unknown A, B, and C. And then determine support reaction. You know how to determine support reaction. You have to take span A, B, and then span BC. Take moment about either A or B, whatever manner it is done. And then you can able to compute, okay? By taking moment, because you know the moment it supports. By taking moment of the forces about the support and equal to that moment, you can able to compute the support reaction. Okay, this is the way the problem has been solved here. It's a worked examples to go through. That's all. With that, the chapter is over in the textbook. Okay, it is well taught. So that's all about how to but you don't worry. It's a lengthy problem. You will not get such a lengthy problem during exam. That to in our institute. When compared to the question paper of several universities in India, really our institute asks very simple questions only. You do not worry. Okay, I advise you to work hard. Without hard work, you can't. Okay, for your betterment, for your future, you have to work hard. You have to apply your mind. You have to struggle, and you have to come up in your life. Okay, so because we have come up like that, right? Nobody have done spoon feeding for us. Everybody has done their best. They taught us. Okay, so strictly speaking, no one can teach others. One can learn from others. Okay, you should have the habit of learning from others. With this, I will stop today class. Okay. Anything if you want to discuss, we will discuss later. Okay. I will first I will record your name for not attendance, just for record purpose. I will name your name, record your names because the video is being recorded, so your names are well recorded for record purpose, right? So I have been recording your name. Okay, I've been recording your name. Your name is being recorded here. Okay, so I should have moved slowly, right? Abhishek, okay. Your names have been recorded. I don't want to read out the names. It's should be clearly visible here. Okay, so your names have been recorded, right? So first I will stop recording. Afterwards, if you want to discuss anything, we can discuss.